Welcome back, Mindsetters. If you've just joined us, we are doing Euclidean Geometry for grade 10s today. It's already been such an awesome show, and you guys, I'm sure right now, you have some questions. So I'm really looking forward to hearing all the questions that you guys have said and done. Also, I might have written grade 102 on the page instead of grade 10. You guys know what I mean, right? I mean, if we're in grade 102, I think we'd be in our, like hundreds or something. We'd be so old that we wouldn't be doing that grade. So you guys, of course, know what I meant.
Yeah, I mean, at one grade per year. So
Imagine.
You can imagine how
we'd
old
be
you would
102 years old.
Okay. All right, shall I carry on?
Yes, you can.
All right. I'm done about triangles.
Okay.
And I think you said someone asked a question
Yes.
about triangles.
Yes,
and
Dr. Fulani asked, so does that mean the hypotenuse only exists in right-angled triangles?
Yes, this name, it's only defined in, you'll remember in trigonometry, because now trigonometry is just something that is going to branch off from this Euclidean geometry.
Yes.
So we have reserved that name for the largest side in a right-angled triangle. Okay.
Okay.
You will never come across that name when you've got obtuse angle triangle or acute angle triangle.
Okay.
All right.
Thank you.
Right. So I'm done about triangles, and I'm going to move on to quadrilaterals. All right. So with triangles, I did classification. And, there's a whole lot of theorems that we could do, but for grade 10s, we don't have to do it now. And I'm going to move to quadrilaterals. Quadrilaterals, that means four-sided. So that is four. And obviously lateral, like I said earlier on, has to do with sides. So four-sided figures, geometric figures, are called quadrilaterals. So their properties. I've got a very useful acronym here. This acronym, I say Dr. PQRST. And that thing has got all the names that you will come across about quadrilaterals. D stands for, already I've got it here. D stands for diamond. The R, if I can just quickly go through this so that you get familiar with this quickly. So that could be a rectangle or a rhombus. So let's take a rectangle here, or maybe a rhombus, yeah, because I think it's nicer to have a rectangle next to a square. So let's call this one a rhombus. That's that. A rhombus. Then the P will be for a parallelogram. I'm taking it slowly because I'm hoping that you're taking notes. Then Q, that would be a strange one for you. Let me just go across there and call it a quadrilateral that fits inside a circle. So it's got no special properties except that it's inside a circle. So we call it a cyclic quadrilateral. Cyclic quad, and the R then stands for, let me use this again, that stands for rectangle. I hope you're taking notes. The S stands for a square. Okay, and finally, T, you can guess, it's obviously trapezium. You can think of any other quadrilateral, it will not be out of that acronym. Okay, so that's Dr. PQ RST, probably hearing it for the first time. So a diamond. Now, I want to discuss properties of these different quadrilaterals. So a diamond is also called a kite. For a diamond, earlier on I said to you, we're going to, yes, we'll have the name of a shape, then we'll talk about, in describing the properties, we'll talk about angles, we'll talk about sides, we'll talk about symmetry and diagonals, regarding that shape. All right, So I have listed there for a diamond that you've got one pair of opposite angle that are equal. All right, so if I can just draw this quickly, a diamond looks like that. A bad one. So something like that. I'm usually good with drawings, so let me just try. Yeah, that's much better. So that's what we call a diamond, and it's also called a kite. So properties of this kite is that one pair of opposite angles is equal. And that pair, in this case, I'll mark it as that and that. If I give this a name, let's say A, B, C, D. Okay, now I can say angle B is equal to angle D. All right. The other opposite angles, they are not equal at all. All right. If they are equal, it becomes a special case where you get a rhombus or something. But yes, what distinguishes a rhombus from a kite is exactly that. It's a showcase that one pair of opposite sides must be equal. All right. That is enough about the angles. Oh yeah, of course I said opposite. So we also have adjacent angles. So now I'm talking about angles that if you were, things were standing next to each other, that would be the next in the list, okay? So you've got this angle. If I'm moving in that direction clockwise, next angle will be angle D. As you can see, I have not marked A to be equal to D, so that's what I mean by adjacent angles not equal. So A is not equal to D is not equal to C, and C is not equal to B, so on. So that's what I mean by adjacent angles are not equal. Talking about sides now. Opposite pairs are not equal. So in other words, if I look at AB, I can make a statement that they are not equal. I mean, AB and CD are not equal. All right. And also AD is not equal to BC. Okay, maybe I must write that. AD also not equal to BC. Okay, so that's about opposite pairs are not equal. And there are two adjacent equal pairs. Something special about a kite. So if you look at AD, side AD is adjacent to, let's say, CD. It's next, if you are looking at the lines, it's next in line, or as you're counting that. So AD is not equal to CD, yet CD equals to BC. So that's what I'm suggesting there, that there are two adjacent equal pairs. So this side will be equal to that. BC is not equal to AB, but AB is equal to AD. Okay, I'll mark them differently like that. So those are the two pairs of adjacent sides that I'm talking about, which are equal. All right. Then we have talked about opposite and adjacent. Now we need to talk about symmetry. So you will see that this language will stick on this table I'll use for all the other shapes. So if we talk symmetry, this quadrilateral, there is only one way I can cut this thing. If I use a different pen there, let's take that pen. So I could cut this right in the middle there, and that point can be folded over to come and coincide with point B. All right, so that's one line of symmetry. There's only one line of symmetry in a kite. And what about the diagonals? The diagonals of a kite, only one diagonal bisects the other diagonal perpendicularly. So by that I mean a diagonal, by the way, is a line that goes from vertex to vertex. In this case, in this quadrilateral. All right. So I'm suggesting that that will be equal to that. So only one line, only one diagonal is bisected. So AC bisects BD, but AC itself is not bisected. Okay, so that's what I'm suggesting there. So we talked about a diagonal there, and the keyword, bisecting, and perpendicularly. So when I say it bisects the other line perpendicularly, I'm suggesting that this angle here is 90 degrees. All right. So that's how you can describe a diamond or a kite. Then we can move on to the next shape. All right. The next shape I have here is the rectangle. Yeah, let's do the rectangle now. The rectangle, remember in your Dr. PQRST, that could have been a rectangle or a rhombus. It's up to you. So in this case, I've chosen it to be a rectangle. All right, the name is rectangle. What about the angles? So let's draw a rectangle quickly. A rectangle would look like that. All right, with the, okay, you'll see, we'll actually do this description up there. All these angles are equal, and that side is equal to that, and it's also parallel to that. We must put that in our description somewhere. So that is equal to that, and also parallel. All right. So let's call this thing, okay, that's that. Let's call this thing A or PQ RS, just to break the monotony there in terms of naming these shapes. All right, so we've got a rectangle PQ RS. I think it would be nice if I kept the direction the same. If it's clockwise, keep naming it clockwise. So we've got rectangle PQ RS in this case. So let's start describing this thing. So what we can see is that the opposite angles are equal, and they are actually equal to 90 degrees. The adjacent angles, they are also equal and equal to 90 degrees. So that you could have made a statement that all angles equal to 90 degrees. That would be fine. So what about the sides? The sides, as I've marked it here, that side equals to that side, but this side is not equal to, so PQ is not equal to PS, so the opposite angle, opposite sides. Opposite sides are equal and parallel. So I would like to use that abbreviation there for parallel. So I've talked about the opposite ones. And how many are they? So there's, okay, I did say, so you've got basically PQ parallel to SR and equal to SR, PS parallel to QR and equal to QR. Okay, so opposite sides are equal and parallel. I think that's good enough. All right, so the adjacent sides, so you can boldly say they are not equal. Adjacent sides are not equal. PQ is not equal to QR, QR is not equal to SR, so on and so on. All right, and let's talk about symmetry. So the language is the same. You can see we're talking about angles, sides, symmetry now. If you have that PQRS as a rectangle, and you introduce lines of symmetry, I can only see two. The vertical line, let me just use a different color there. All right, the vertical line will cut this into two equal halves, no problem, and the P will coincide with the Q. If you fold on the, your shape on the line of symmetry. All right, so the same would happen if you had a line of symmetry that is horizontal. Okay, so you've got two lines of symmetry. The point here is that you've got two lines of symmetry. And that's it. What about the diagonals? The diagonals, now, if I can just redraw this quickly. All right, let's get that pen again. Now, let's show the diagonals there. The diagonals will then be lines that go from vertex to vertex, S to Q, P to R. Now, guaranteed, these lines bisect each other. So in other words, if this is O here, SO will be equal to OQ, and PO will be equal to OR. And how do you write this statement? We will say diagonals bisect each other. Now, if you want, you can just emphasize that not perpendicularly, because there's something about these things, these diagonals bisecting perpendicularly. It's only for certain shapes. So you could, for your own benefit, just say not perpendicularly. So, all right. And I think I'm done with the properties of a rectangle. And Katleho, we can take
a break before you
small break,
continue.
yeah,
Okay,
yeah.
let's take a very short
All
break
right.
before you guys continue with your Euclidean geometry. Remember, at this point, it is a very good idea to ask some questions. See you right now.